everybody. So today we are doing 4-4 day 1. This is just reviewing stuff that we did like way at the beginning of the year. So the square root function maps each domain value to its square root. So thinking about square root, what does square root even look like? Well, it looks something like that, doesn't it? So that is the parent function. That is the plain base version of this. Now, the parent domain. If we went on to Desmos, so everybody today is going to need to have Desmos. Go on to Desmos, type in square root of x, see what it looks like. Domain, don't forget, is all of your x values, okay? So it's everywhere that's going across the x-axis. So from left to right. Once you get that, you're going to see, hey, it goes from 0 all the way until infinity. So if I was doing this one, let's say I have a dot here, and then I have a dot somewhere here, and then somewhere like right here, and then here. So it's going to look something that just goes off this way for forever. Now, the range. Range is all of my y's. So I want to know all my y's. So that means I'm looking at from the bottom to the top. Okay, so we're going from bottom to top. If I was looking at this at the bottom, where is that first point at on my y-axis? It's at 0. So I'm going to say the range is from 0 till infinity. It's going up for forever. Now, one thing to remember, you have to use a bracket if it's equal to. So if there's a dot directly on that, or if the line fully touches, so there's a closed dot there, then it is a bracket. If it's like infinity, you can't ever hit infinity, so that's going to be a parenthesis. Okay, so let's go ahead and do our parent table. Parent tables, for us usually we use -2, -1, 0, 1, 2. But for this one, I can't have any negatives. So I'm going to go 0, 1, 2, 3, 4. Now, just looking at my little graph that I have here, f of 0 is at 0. F of 1 is at 1. F of 2. Now, this is where you can either use a calculator and do what's the square root of 2, or you can just, if you've already typed it into Desmos, you can type it again and say, okay, x equals, and then plug in 2 and see if what that gives you. So when we do that, we should have 1.414. 1.732, and for 4 we should get 2. So that looks like that's basically where I had all my dots. Cool. Okay, the domain of the square root will change when h transforms, or has with h transformations, and the range of the square root function will change with k. So remember h and k? The way to remember this is f of x equals a square root of x minus h plus k. So remember that. That's something that's important. We did this earlier in the year. I know everybody remembers learning this. This is the most important thing that we've learned all year. Okay, so for the next one, what is my parent function for a cube root? Well, a cube root is the same thing like a square root. It just has 3. So we're going to write we have 3 root of x. Okay, so go ahead and type that into Desmos and see what shape does this thing make. Okay, so we should have gotten an S. Now, let's go ahead and just fill out our parent table values. So like before, -2, -1, 0, 1, 2. Those are always the numbers that we're going to use for our x's if it actually goes everywhere. So f of x is, or at -2 is -1.2599, -1, 0, 1, and 1.2599. I got those based off of where I put my points, or where Desmos said it was at 0 or -1, -2, 0, 1, 2. Okay, so now domain. One more time. Domain is my x's. So going from the left to the right, where does this thing go? Well, it looks like there's an arrow going on, so that means it's going for forever. So -infinity Off to the right, where does it end on the right? Positive infinity. My range, that's my y's. Where is it at the bottom? Well, it looks like it's going down for forever because there's an arrow going down. Like it's not like ending up at one point. So I'm going to say negative infinity. And then is it going up for forever or is it stopping somewhere? It's going up for forever. So we're going to put positive infinity. Same thing down below. The domain is just, or will change with h transformations, and the range will change with k transformations. And y equals a cubed root of x minus h plus k. If you remember back, this is what we were working with the whole entire time, a, h, and k. Okay, so for the next one, looking at this, I want to determine my range and domain. So the first thing that we're going to want to do is figure out what our parent graph is. Do you guys remember learning this? So we have our parent and then we have a child graph. So for the very first part, my parent, these are my x's, and then I can write f of x here. So same thing as before. You can use the same thing that was on that front page. So we have 0, 1, 2, 3, 4, 0, 1, 1.414, 1.732, and 2. So you could use that. That is perfectly fine with me. For my child graph, again, we have f and f of x. Now, can anyone remember what the rules were for changing our x's and our y's? Well, it's x plus h. So looking at this, what is a? A is negative 2. What's h? H is positive 3. And k, is there anything for k? No, there's not. So I'm just going to put an x there. There's nothing. It doesn't count. Okay, so x plus h. So I'm going to take my x that's sitting over here. I'm going to add 3 to it because that's what h was. So 0 plus 3 is 3. Now I'm going to take 1. 1 plus 3 is 4. Now I'm going to take 2. 2 plus 3 is 5. 3 plus 3 is 6. And 4 plus 3 is 7. Okay, for the other one, the equation is ay plus k. So if we look at these ones, that's basically my y. So I have a, which is negative 2, times 0 plus nothing. So I'm not going to put anything. So anything times 0 is just 0. Negative 2 times 1 is negative 2. Negative 2 times 1.414. That is negative 2.828. Negative 2 times 1.732. That is negative 3.464. And then negative 2 times 2, that's just negative 4. Okay, so I'm going to go ahead and just graph these points. So we're going over to 3, so it looks like everything on the x-axis is going by 2, so 2.5. So that's 3, and then 0. So I'm going to put a dot right here. For 4, I'm going over to 4, and then I'm going down 2. So it looks like 2 is about like, I don't know, somewhere that's right here, because everything's going by 5. So this is 5, 10, 15, 20. 5, so that's over another half of 1. And we are going down to 2.8. So I don't know, something that looks like that, somewhere around there. 6, again, we're just getting closer and closer to that point. And then 7, down even further. So I'm going to draw my line. It starts at this point and it goes off this way, remember? Because if we looked back at our old graph from the first page, it's literally just like a little swoosh that happens. So this is it. Now, looking at this though, I want to know my domain. So I'm going to go ahead and write my domain. Domain are my x's, right? So it looks like I'm starting at 3 and I'm going on for forever. So 3, infinity. My range are my y's. So looking at it, where's the bottom of this thing? Well, it looks like it's going down for forever. So I'm going to go ahead and put, I have negative infinity. and then it's going all the way up till 0. So I have 0, this should be a bracket. So negative infinity, comma, 0 with a bracket. Okay. So real quick, we're going to go ahead and write what A, H, and K are. So A equals 1/4, H equals -1, and K equals -1/2. So remember, H, we always flip it. So if it's a +1 there, then that means I'm going to flip it. So it becomes a -1. Okay, so I want you to go ahead. You don't have to do the parent graph or function or table if you don't want to. For you to go ahead and figure out table, and then I want you to graph it. Then I want you to go ahead and tell me what's your domain, what's your range. So go ahead and work on that one. Okay, so let's double check that we got the same thing here. So my x's, I have -2 minus 1, so that's -3. -1 minus 1, that's -2. 0 minus 1, -1. And then 1 minus 1 is 0, and 2 minus 1 is +1. Same thing over here, so 1/4, so I want a fourth of that whole entire thing. I went ahead and just looked at Desmos to see what it would actually give me, so that is -0.8149, -0.75, -0.5, -0.25, and -0.185. So my graph is going to end up looking something like this. So we're going to -8, so that should be there. -2, -0.75, that's somewhere there. This is here. This is up here. This goes to right here. And then I didn't know anything else further than that. So looking at my graph, it looks something, it's going to keep going up somehow, but something like that. That's just a rough sketch of what I think it's going to look like. So my domain, this is the main part that I wanted to see. My domain, -infinity to +infinity. My range is, again, we're looking at it, goes down, goes up for forever, so -infinity to +infinity. That's all I'm really looking for. Okay, so I'm going to go ahead and end this video, and then I'm going to go on to the next one, so make sure you go to part 2.